final review. Well, this is the first review of your final.
Is it at the end of the week?
All right. It's what now?
When is it?
I don't know when it is. It's not next week. The week after that's Thanksgiving.
It's
Then-
the end of the week that we get back from Thanksgiving break.
Really? So you don't even go into December?
No.
That's why we're getting started now.
Wait, I think it's that Monday. I think it's the Monday of like.
No,
Oh,
our exams
no.
that Friday,
You're
the
saying
last Friday.
Friday, November 30th, maybe?
Yeah,
Yeah, that's when it is.
Oh, so sure.
So that means
That's
we've
when
got
all-
today, we've got next Monday, we've got next Wednesday, and we've got a Monday and a Wednesday again. So that's 5 sessions for us to do this.
We
That's
did the
great.
first one at 4, so.
Yeah, I don't know if we covered every problem, but here we go. Some of these will take a little bit of time. This first one deals with Riemann sums, okay? Just kind of looking through this. We might hit that one first. This second problem deals with the change of variables or using the table, and they provide the table right down there. I actually think this one is a change of variables problem looking at it, but this one is a conceptual problem dealing with the Riemann sum. Then you've got some problems dealing with f and f prime, whether it's a derivative or an antiderivative. A problem dealing with the properties of integrals along with the boundary values, and kind of being able to combine some of those. This one literally looks like find the area. And does anybody know how to use the calculator to find the area of under a curve just like that? You know how to use that? I mean, like a legitimate regular calculator. We can show you how to take care of that. That might also be helpful for your homework. We've got a limit problem dealing with L'Hopital's rule and indeterminate forms. Looks like something dealing with motion, finding the average velocity over some different regions. Another physics problem, once again finding the average velocity. And then some more L'Hopital's rule, limit problems. Another velocity and motion problem. This time they're giving you a table and trying to find Riemann sum. So this is what I call a data-based problem. So like a table-based problem. Find the midpoint. Then we've got another function defined by an integral, and you're going to have to do some things with it, finding the integrand, graphing the derivative of the function, as well as the function itself. Given a function, finding the constant of integration. Some more physics-related problems with some initial conditions and finding the average velocity. Average velocity seems to come up a lot, doesn't it?
Yes.
Yeah, that's great. We love the velocity because it's below the position and it's above the acceleration. You do all kinds of fun stuff with that. Velocity's the sweet spot there. Some stuff using the fundamental theorem of calculus. Looking at some graphs and doing some analysis based on this is an area function. Oh, and that's it. For a total of, yes.
Oh, 15.
15, okay.
That's not good.
I don't know if that's
Probably
good or bad.
very, very long.
Is 15 very long?
No, like the
Short
word.
with things like these.
Or you think maybe the problems are
Yeah.
collectively?
That makes sense,
When
Yeah.
take out like any of the chapter 6 questions.
I think you
Oh,
already
that's
did.
yeah, you
true,
already
yeah.
did.
Is chapter 6 deal with volume?
I think you just went to chapter 6.2 max. Like max, we have to go to 6.
All right.
Yeah.
You don't remember in class you said when you might still have the first, the first two.
Got all the homework already. That's what he said.
Okay. This one's pretty good. Number 13. I want to kind of look for some. I don't know where y'all are on the homework and stuff like that. But maybe if I can show you some easy problems, maybe that'll help you with the homework.
Yeah.
So, but the easy ones you probably know how to do. But that's okay. So number 13 here, it says if f of x. I don't know if y'all can see that. Make it slightly larger. There you go. If f of x is equal to 3x squared plus 8x plus c, and f of negative 1 is equal to negative 4, what is the value of c? Okay, well that really doesn't even, I don't know if that's a calculus problem or not. Okay, so, but let's go ahead, look at that. So this says, here's the function, and when you plug in -1, you're gonna get -4. And so, I can go down here and say, plug in -1, so alright, f of -1 means 3 times -1 squared plus 8 times -1 plus c, and they tell me that that equals -4. So 3 times 1 squared is 3, minus 8 plus c equals -4. So 3 minus 8 is -5, plus c is -4. So according to my calculations, c is equal to 1.
Yeah.
So
I
we
got
got
it.
Let's see if it's really that easy. We are correct. Alright,
Get one question.
so there you go, 13's done. Not sure how that snuck on there, but you know what? We'll take it. Let's find that other area one. I hate it when we spend the first 1 or 2 times going through like 2 problems, you know what I mean? See if we can get some problems under our belt. I guess we could talk about average velocity. There was one of these that was not too bad. Well, must have been before number 13. Perfect. This one's really good right here. I can even graph this by hand. So number 6. Find the area of the region bounded by the graph of f and the x-axis on the given interval, where f of x equals x squared minus 20, and then they give us the region from 2 to 3, and they want us to find the area. Okay? I'll show you how to do this 2 different ways, a hard way and easy way. So, if we graph this function, you graph it on your calculator. I happen to know what this one looks like in my head, even though my axes don't have that. You probably do too. F of x equals x squared minus 20. What is
So you
this
go
gonna-
down to -20.
You go down -20 from our y-intercept, and it's going to be a parabola opening upward. So there's -20. And they want us to find the values between 2 and 3. So 2 is going to be, you can use your calculator, but 2 squared is 4, so 4 minus 20 is -16. So right about there. And 3 squared is 9, 9 minus 20 is -11, so we're still down here in negative territory. And they want us to find the area of the region bounded by this graph and the x-axis on the interval given. So this is 1, 2, 3. So we're looking at a sliver that kind of looks like that. Alright, so the formula for the area is equal to the integral from a to b of f of x dx. I say the integral, I know you're familiar with that terminology. Also, there is another name for this symbol right here. Anybody know it? Integration, yes, that's the process. This is the antiderivative,
Oh, yeah.
Either way.
okay? So
I just said a word.
it's the integral, it's also the antiderivative. Derivative. Alright, so in this particular case, our A and our B are 2 to 3. So put 2 there, 3 right there. Our function is x squared minus 20 dx. Sometimes we'll put parentheses around that just to make it nice and obvious that this is the integrand. And that's it. So now what we need to do is we need to apply our antiderivative rules. Okay? And the antiderivative rules are the opposite of the derivative rules. Okay? So normally, if I had a function, I'll say g of x is equal to x squared. The derivative would be top down, power down, 2x to the first, right? But that's not what we're doing here. We're doing the other thing around. We have a situation where we have h prime of x is equal to x squared, and I need to go this way to figure out what h of x is. Okay? So I need to do the inverse process here. I think we walked through that last time on the review, right? So you're super familiar. So does anybody know how to do the antiderivative of x squared? Jessie, it looks like she knows.
2x to the first.
Nope, it's not 2x to the first.
Divide by
That's
2.
that's what I would if I was going here and here,
I'm not
X to
aware.
the third.
it's gonna be x to the third, that's right.
Divided by
Over
2.
2.
Oh my gosh.
Not over
Well,
2.
it's
Over
'cause they're
3.
It's gonna be over 3.
Because it's n plus 1. It's like, it's x n plus 1 divided by n plus 1.
That's right. The general form is if you have f prime of x equal to x to the n, then the original function f of x is what she was saying, x to the n plus 1 divided by n plus 1. And the reason is because if you were to take the derivative of this, you would pop down the n plus 1, which would then cancel out this denominator, and then this would just be n. So, going back over here. Antiderivative of x squared is x cubed over 3. And the antiderivative of 20
20x.
is 20x. Okay? Now, we still have to deal with this 2 and this 3. Okay? Now you might say, oh, I know what I need to do. I need to put plus c, right? Okay? No, you don't. There are actually 2 different types of integrals. This one right here is what's called the definite integral because it definitely has numbers. Okay? It's a bad joke. It's definite because it's defined, okay? And it has numbers right there. And the fundamental theorem of calculus says that, I'll put it over here, second, that's the good old FTC. They say on these questions the fundamental theorem, but that's what it is. The integral from a to b of f prime of x dx equals the original function evaluated at b minus the original function evaluated at a. Okay? Pretty amazing thing if you think about it. But anyway, so as that relates to this, okay, just as a side note, alternate idea here, the integral of f prime of x dx is equal to f of x plus c. That's when you're dealing with your plus c, okay? When you have an integral, but you don't have things, numbers there on upper bound and lower bound. This one right here is called the indefinite integral. Indefinite because it's not, it doesn't have boundaries, it's not defined. Okay? So make sure you know the difference between the definite integral and the indefinite integral. If for no other reason to know, we need to put the plus c and we need to do the f of b minus f of a. Okay? So, have y'all done problems like this? Where you've got those numbers here and here? Not quite yet? Okay. So, let me, so the notation that we use, and we can do other problems if we need to like this. The notation is we say, we put little brackets around that, and then we say we want to evaluate this from x equals 2 up to x equals 3, which, I'm sorry, I'm just, I'm kinda just like showing you answers here, like we're kinda going through, and it's not I mean, obviously, it's not the best way, this is meant to be a review, so I'm just doing problems, rather than building it up, and we're kinda doing some side explanations on the side, but.
I mean,
It-
you can only do so much.
It is what it is, alright, so but just follow along, when you do another one, that's no big deal. So, the way we apply this is it literally means plug in 3, so I'll do, 3 cubed over 3 minus 20 times 3 minus 2 cubed over 3 minus 20 times 2. Okay, that's, when we use this notation, the lower bound and the upper bound here, it means plug the upper bound in, then have a minus sign, then plug the lower bound in. That really makes sense. Okay. And then, you just kind of type it all out and figure out what you get here. So this would be, 27 divided by, I guess you have 9 minus 60 minus 8/3 minus 40. Someone with a calculator can run those numbers here for me. They say the answer is 41/3. Does that match what we've got? 9 minus
Yes.
60, okay. Alright. Based on some looks that I'm getting, I would like to do another one kind of like this. That's okay with you, Harley?
Mm-hmm, that sounds great.
Okay, let's do another one like that.
Okay, I don't care, I'll take it.
So, we'll say the integral, we'll do something a little bit more basic, of x cubed from 1 to 5. Okay. So just throwing up a definite integration problem there. Here we go. So remember the rule that we saw over here. This is kind of hidden in the corner, but it is one of the most important things written on the board. If you have a derivative that's f prime, I'm going to do a lot of these here, f prime of x equals x to the n, then the original function is x to the n plus 1 over n plus 1. So the antiderivative here would be x to the 4th over 4. And then we're going to evaluate that from x equals 1, x equals 5. And like I said over here, what this notation means here is we plug in the 5. So we have 5 to the 4th over 4 minus 1 to the 4th over 4. And what do you get with that, Emily?
For the first one is 156. I'm not done.
Okay, yeah. And then just subtract 1/4, I guess. So what's it?
156.
156. Okay, that's not too bad. Let's do one more just to solidify what we've got. We'll say the integral from 3 to 7 of, we can do something like, I can say x to the 4th plus x squared plus x plus 1. Dx. Rigel, how you feeling about this antiderivative power thing right here? Can you help me apply it here with this x to the 4th situation? Okay. Well, I want you to look at here what's going on. So, when you have something in an integral, let me just make it this. So, the integral, just looking at x to the 4th all by itself, okay, is going to be x to the 5th over 5. Okay? I would put a plus c, but I'm just doing some basic stuff. The integral or the antiderivative of x squared would be x cubed over 3. Alright? So what I'm doing is I'm applying this formula. Now there's probably some misconceptions going on here, misunderstandings, because you're like, you've got this f of x and stuff like that, and then you've got this big S with a stretched out thing. And I know that the thing is that what we're looking at, this part right here is the derivative, is this f prime. And what we're trying to solve is, given the antiderivative, what would be the derivative, which is given by this one right here, x to the same exponent plus 1 divided by that particular exponent. So I understand that it can be confusing, because according to this box that I have written, we're going from here to here, and according to this, I'm going from high to low, but I'm sure y'all can adjust and handle that. So literally, we just need to know the power rule for antiderivatives with exponents.
What would it be for 1?
Great question.
Is it the one that you wrote over here? Or is that different?
You
Uh,
would do something like that.
Yeah, I have an H. Okay, so I'll just do it all one by one right down here. You can see it. So we know that the antiderivative of x to the 4th is x to the 5th over 5. We know the antiderivative of x squared is x cubed over 3.
X squared over 2.
Okay, so the next one would be x squared over 2, because that's essentially an x to the 1st, correct? So this other guy right here, 1, you can think of as 1 times x to the 0. So keep that 1 right there, and this would be 1 times x, push it up here, x to the 1st, and then divided by 1. So 1 times x to the 1st over 1, that's a whole lot of 1s. I would simply write it as x. I wouldn't even put the 1. I would just say x. You can check yourself by analyzing what's the derivative of x? 1. Okay? There's one more problem that we need to do after this, because I haven't done any of these with coefficients, but that's just a simple thing. Oh, I was putting the brackets there. Alright? Bracket, from x equals 3 to x equals 7. I feel like y'all are pretty good at this part, right? Plug in 7. We'll plug in the. There you go. Give it a shot.
Thanks.
Yep. So plug in 7. So that would be 7 to the 5th over 5 plus 7 cubed over 3 plus 7 squared over 2 plus 7 minus 3 to the 5th over 5 plus 3 to the 3rd over 3 plus 3 squared over 2 plus 3. And we don't even need it. This is just a made up problem, so I don't really care about the final answer on that. But y'all can type that in the calculator. I'm just mostly concerned that y'all know how to apply those bounds. Okay, so the one variation that you could get with this is if there's a coefficient. Something like, what if it was 3x to the 5th dx from 0 to 1, okay? And if there's a multiplier out there, like all things good in scalar multiplication, you just keep the 3 there. You say the antiderivative of 3x to the 5th is just 3, and then x to the 6 over 6. Hooray!
So 1/2 x to the 6.
Yeah, so 1/2 x to 6. And, I mean, and this would be evaluated from 0 to 1, and you can go from there. I just want to make sure you deal with that so you don't freak out and see a scalar multiple. 9 times out of 10, if you see a scalar multiple, you just kind of keep it out front and hope that it works. 'Cause actually it does a lot of times, thank goodness. Okay, so we got a final answer for that of the area, but Something doesn't feel right about this.
Isn't that the answer they gave?
It is the answer they gave.
So it's right.
I don't know.
Wait, so
I don't
we're
think
done?
you, I don't
Let's
think
not do that.
y'all told me the right answer.
What?
I think I wrote that answer down and then y'all said yes.
No, I
Negative.
thought she put it in her calculator.
Wait, is 3 to the third divided by 3 9?
No, but, 3 to the third is 27, divided by 3 is 9. I'm just saying, what's 9 minus 60?
Negative
Negative
51.
51.
Negative 51. And what is negative, and then, okay, so what's 8/3 minus 40?
Negative 30, negative 37.3 repeating.
Negative 37.3.
Which would be plus, which would mean it would be negative,
Which means it would be negative 51
plus
So our
35,
plus
answer would be negative.
which would
37.3,
be negative.
which is negative 41 point, negative 41 thirds. Is that right?
Yeah.
That's
Okay.
just-
Okay, so I was right. Okay, so there is something wrong with all of this. Okay, and so the thing is I wrote 41 thirds over there, and y'all said yes, but in reality, what your calculator was giving you was negative 41 thirds, but y'all ignored it, and I didn't catch it. So we're all at fault. Okay, as luck would have it, though, we had by a happy situation, we got the right answer. So let
That
me
would make sense because it's,
below the x-axis.
yeah.
Yes, okay, so here's what I would say. This sucker right here, alright, that integral from a to b of f of x dx, okay, if we're talking about a region down here below the x-axis, it's going to give a negative number, okay?
Can we write it in as a negative number?
Well, here's the thing.
Because area is positive.
Because it says what's the area, okay, it does not make sense to talk about negative area.
So we don't write the negative.
So, after you do all this and do your analysis and find out that it's negative 41 thirds, okay,
It's still positive.
then you need to say, and I need to take the absolute value of that to find the area.
So we technically were right.
So, we were accidentally correct. Yes. Now, you might say, well, okay, why don't you just then put absolute value bars around that? Right? That seems to make the most sense. And I'll show you a weird situation. Hopefully, I don't know if it'll come up on your test, but it might come up on homework. Where in same graph, but what if they had said from 2 up to 5? Find the area under the curve. Find the total area. In that case, you would have all of this area plus all of this area. Okay? If you said what's the area between the curve and the x-axis, okay? The integral from 2 to 5 of f of x dx would give you a negative number here and a positive number here, and would actually give you a lesser value than what the real area was. So the integral for this region right here is going to give you a negative number, like negative 50. The area for this one right here is going to give you a positive number, like, for instance, positive 100. And if you just do the integral from 2 to 5, then that's going to give you an answer of positive 50, which is the combination of those two. But if I'm asking literally what is the area, like what's the space of this plus the space of this region and this region, like together, it's not 50. The region of this and this is 150. Probably just confusing the matter here, but that's why you would. This is why you wouldn't just say the area is equal to the absolute value, because it's not. Okay, that's enough of that. Would you like to see a way that you can type this into your calculator and just get the immediate numeric answer?
Yes.
All right. It'll help you out with numeric derivatives or integrals, but it won't help when we have to do the plus C and other things, but you need to know how to do this anyway. Let's find the one that we did do. The blue calculators are better for this, so I recommend you get a blue calculator. Alright. Go to the math button, since we're in math class. And then go to the very bottom of that. We want the finite integral. That's the FNINT function. If you've got a blue calculator, it formats everything nice and pretty for you.
So I'm not telling you.
Oh.
Ding, 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 then you plug in the numbers.
Are we using the original problem?
Yes, the one on the right there, since we know we have an actual, we know what the numeric answer is. So you hit the math button, then finite integral, and then plug in 2 for the lower bound, 3 for the upper bound, x cubed minus 20, and then you want to put dx. So you actually hit the x variable key, not the x.
Did you ever repeat this like that? It's not. Wait, oh, that's a different problem.
Oh,
You were
I-
20.
20x.
Okay, now
Oh, it's not the same problem.
correct.
It's 20x?
No worries.
I got a
Yep.
different answer from Rigel.
Oh, just kidding, I got it.
X cubed minus 20. Oh, that's, I wrote it down wrong, sorry. It's x squared. That's the problem. X squared minus 20.
Alright, there we go.
It's good, I know this one.
We made it there.
We can handle the calculus, but we can't handle copying a number down. And by we, I mean me. Yeah, okay. James, you good? Finite integral? I haven't get you caught up to speed.
All the way to the left.
Alright, so we're calculator.
Do it.
Yep.
And then that.
I don't know how. I just showed you.
Okay. So there you go. That's one of the 4 things required on the AP test. We're going to take an AP test, so. But it's kind of required for this test, looks like.
There you go.
Okay, everybody good on that?
I got the wrong answer.
Did you type it in wrong?
No.
Alright then, let's look at it. Did you hit this X or this X? The X down here.
No, I hit the X at the top.
2, 3 of x squared minus 20. I don't think that's a minus. I think that's a negative.
I don't know when this is coming in for me.
Who cares? It's minus anyways.
Oh, look at that. It's the right answer.
It's not gonna help you. It's not
Alright.
gonna make you use your
I thought the balance of the universe was upset for a moment, in which case the calculators were giving the same answer for the same thing typed in. Okay, so, well, I was hoping we get like 5 or 6 problems knocked out, but we get 2 of them there, so that's okay. Let's see if there's another nice and easy one.
Is number 5 right there? Like, literally just plugging.
You deserve that.
Somewhat, yeah.
But is it that
Oh, yeah, yeah.
you?
That's not a bad one to do. I wanna, yeah, I mean, I guess we could do, definitely not change variables. Okay, this conceptual one's not too bad. Okay. So we did number, yes, I think I call myself.
13
Let's look at number 4. Fill in the blanks in the following sentence with the words derivative or antiderivative. Okay, perfect. Roger, you're gonna love this. Alright? So if f prime of x equals, so a big F. If big F prime of x is equal to little f of x, Then little f is, anybody wanna make a guess? Is it the derivative or the antiderivative, little f, in this situation right here? Big F prime of x equals little f. Then what is little f? Yep, it's a derivative. Little f is the derivative of f, and big F is the antiderivative of little f. There we go, that one's easy. We'll get time for at least one more, if I can find a good one. I would say, it seemed to me like a lot of these, we can do part of number one. Or one of these that had the average stuff there, underestimate. This one's not too bad here, this is number 3. Because y'all were just talking about Riemann sums this week, right? Okay, so Riemann sums are these guys, when you've got some sort of function and you've got like rectangles. Yeah, we did at the end of pre-cal.
Which I wanna thank you. Thank you.
You're welcome.
Thank you.
So the question is, what is a Riemann sum good for? And the answer is, what did we use it for, Emily?
Like sub intervals. So like we would like make it smaller so that then we could figure out the small ones and then add them all together for the big one.
And what was the purpose of that?
To find the area.
Yeah, to find the area. So under the curve and above the x-axis. So that's a good thing to remember. So Riemann sum is good for, I would say, approximating the area under a curve and above the x-axis. And Emily, you actually said some things which are related to the answer here. And you said, say what you said again about the size.
You make the sub intervals like, and then you figure out like the small little pieces of the area and then you add them all together to get the large piece.
Okay, yep. So you find like the area of this rectangle, and the area of this rectangle, and the area of this rectangle, then you can find the area under, the curve between here to here. Now, I would always ask the question, I asked it about 20 times, how could we get a more accurate answer for the area under that curve?
Make them smaller.
Make what smaller?
The subintervals.
Make the subintervals smaller, right? Okay? So, like one of those, and one of those, and one of those. Okay, so we got little, they're still rectangles. Okay? So, as the number of rectangles increases, or you could say, as the sub-interval length decreases, or you could say as you make the width a little bit smaller and smaller, the accuracy increases. Now in this particular question it says, explain how, in general, Riemann sum approximations to the area of a region under a curve changes as the number of subintervals increase. So the number of subintervals, so that means the number of rectangles increases. Okay? This says, first one, as the number of subinterval increase, the Riemann sum approximations to the area of a region become less accurate? No. It says as the number of subintervals, it's the number of rectangles, increases, the Riemann sum approximations to the area under the curve become more accurate.
Yes.
That is correct. So it's a matter of knowing the terminology. So there you go. There's number 3. And on Monday we'll do a little bit more. Thanks for watching.